All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 115 is on the screen. So by now, you guys are experts at that. And today, we're moving on to one more type of distribution. And we'll get to that as soon as we're done with this. So give you some time, copy and go. Also, thank you for sending your warm-up already. All right, copy the agenda. Warm-up number 115, discrete probability distribution, and 2 problems only for tonight. We did a cumulative review last week. We ended up the week with a pop parte. I thought it was fairly simple and straight. And today we're just going to add one more component just to close this section up. And I think by the looks of it, I might be asking you to bring your books back by now. Ooh-wee. You know, like Mr. Q, it's going to start getting real now. Oh, yeah. Oh, yeah, let's go. Yeah, because April is pretty much done, right? It's a wrap. Right? Because we have minimum day on Wednesday, and then all we have is Monday and a little bit more, yeah? All right? Just take the thank you card. Okay, we got it? All right, copy the code for the access to the home play, FRVSI. 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 Yeah, so pretty much this week and next week, Monday, Tuesday, and April's gone. All right, get a Cornell note going, please. Give you some time to set that up. So our objective for today can define and compute the discrete probability distribution. Like I said, we're wrapping this up today. Where have we been? We already know all this, classical, empirical, subjective. We know discrete and continuous variables, probability distribution. We talked about the formulas for probability distribution for the mean, variance, and standard deviation. From there, we went to binomial distribution, and you know how to find the mean, variance, and standard deviation using those formulas. From there, we went to multinomial distribution, which was that. And that was the end of it, up to right there, which gets us to today. So look up to the screen. So students, let me introduce you to a mathematician by the name of Poisson. His last name's Poisson. We're not going to get into Poisson stuff, but we're going to be looking at probabilities that involve more than just a few numbers. You know how last week with multinomials we did x of 1, x of 2, x of 3, maybe x of 4, is that correct? You're like, yes, Mr. Q, so what are you saying? So what I'm saying is that what if we have x of 20? Ooh, it's going to be funner, right? Right? Am I right? Am I right? So that'll be today. So this mathematician, French, he worked on a lot of calculus stuff, electromagnetic theory, and probability. So he came up with a theorem that is known as Poisson probability. Copy this, please. Just copy the theorem. You don't have to copy the verbatim. We'll get into all the components as soon as you do. Whoa, sorry. So by now we should know already what x is. Is that correct? Yes, Mr. Q. So x is usually the number that they're asking us to find the probability for. In this case, it's known as the number x of occurrences. Okay. However, I'm bringing something in that you saw, those of you that were with me in Algebra 1 or Algebra 2, the variable e. So on the side, I want you to write e approximately, and you're going to write the value of 2.7183. We're going to be using that value, decimal value, for e. Anytime you see e on the formula, you substitute 2.7183. Okay? And last but not least, this symbol right here is known as lambda. It's a Greek letter, and this stands for the mean of occurrences. It says it right here, per unit. And we'll figure that out as soon as we get to the problem at hand. And the rest is history, x factorial, and this is just writing our organization as to what we're looking at. All right? All right, so with that said, copy the first problem completely, please. Example Q. And it reads, if there are 200 typographical errors randomly distributed in a 500-page manuscript, find the probability that a given page contains exactly 3 errors. Copy that. All right, so to get started, let's get organized with the information that we need for our formula. What information do we need? We need our x, we need our lambda, and we need our e. So, write x, lambda, and e. So here the easiest one is e, which is 2 point what? 7183. Yes, that is correct. So, by looking at the problem, what are they asking us to find? The probability of a given page containing how many errors? 3, so that's going to be our what? X. That is correct. And with what we have left, it says there are 200 typographical errors randomly distributed in a 500-page manuscript. So to find lambda, let's write 200 divided by 500. And get that in decimal form. What is the decimal form of 2 over 5? That's 0.4. Is that correct? All right. So now that we have our values, let's use our formula. So we got P of x semicolon lambda. So what is x? X is 3, semicolon, and lambda is 0.4. Next, what is E? Well, E is 2.7183. Put that in the parentheses. And it says to the negative lambda exponent. So what is lambda, we said? Negative, lambda was 0.4. Times, because notice that lambda follows after that, times lambda, it's right here, to the exponent of x. So this is 0.4 to the exponent of x, which is 3. Is everybody following the formula? So far so good, yes? All right, and the denominator is what? 3 factorial. 3 factorial. All right, so with that said, P of 3 semicolon 0.4 is, look up really quick. I'm going to do one more step before I let you guys loose to do your computation. We know that 3 factorial is what? 3 factorial is 3 times 2 times 1. Is that correct? All right, but I want to talk about this number in the numerator. Can we have negative exponents? No, remind your neighbor what to do, especially those of you that were with me in Algebra 2. What do we do with those numbers with negative exponents? I'm going to ask some of y'all, my ex-students, to see if you remember. See if we remember. All right, let's ask Briseida, what do we do with any exponent that's a negative? You what? Yeah, the reciprocal, we send it to the denominator. So this one goes now at the bottom, 2.7183, and we change the exponent to a positive 0.4, times, instead of writing 3 factorial, I'm going to do 3 times 2 times 1, which is 6. And what's the only thing that remains in the numerator? 0.4 to the 3rd power. So I'm going to erase this little piece right here, right there. Once again, did everybody catch where we sent the e to the negative exponent to the denominator? Yes? Okay. And the rest is history. All right. Calculators calculate. Get me a number for that. What is the probability of 3 exact errors on that 500 page manuscript? All right, looks like Daisy's got it. Peyton got it. Very good, Peyton. Chelsea's got it. All right, I see you, Chelsea. But let's go with, let's see. How about Joseph? What'd you get, Joseph? .0030. Oh. And what else? 1. Hands, if you got something like that? We got something different. Let's see. Diego, what'd you get? 00 what? Another 0? 0.0007. Hands, if you got something like that? Yeah, this is a little bit closer. So we'll go with this one. Put approximately. So if you notice, now that we've gotten into distribution, it's more just like crunching numbers, yeah? So the only, I think, the only challenge for us is to make sure we know what X is. X is the probability that they're asking us to find. And E, we already know. The rest is history just by finding a mean or an average using the rest of the numbers, okay? All right, let me send you the screen so you can send me your notes. All right, thank you for letting in your work. Here goes the next one, example mega Q. Mega Q. Write down example mega Q. Don't copy the example. We can just go with numbers from there. Just write example mega Q. And we're going to start with our X. Then our lambda. And then our E. And once again, E is our easiest value, yes? 2.7183. Tell your neighbor what X is. What is X? That is correct. X is 5. And lambda, we're going to take the 2% times 200. So how do you write 2% in decimal? 0.02 times 200. And that gives us, Fernando says 4. Looks about right, yeah, okay. So now that we have those values, get our formula. P of 5, semicolon, and lambda is 4. Then we got E, which is 2.7183 to the negative lambda, which is 4, times lambda to the x, lambda being 4 to the 5th power, and all that over 5 factorial. So let's simplify. Let's see. What stays in the numerator, everyone? Yeah, 4 to the 5th power. So what do I write in the denominator? I write 2.7183 to the positive 4 power times 5 times 4 times 3 times 2 times 1. And that should give me a number. All right. Calculators calculate. All right. Joseph, pass someone. Chelsea, what'd you get? 0.156 looks about right. Hands, have you got that? All right. So, once again, there you go. It's all like I said, all using the formula. Let me send you the screen so you can send me your notes. All right, so for 1 to 5, I'll come to you with that so far. 5, yes? Now, I don't know if you guys noticed, you look up to the screen. Look at the two examples I gave you earlier. Example Q said what? Exactly. And example mega Q said what? Exactly. You're like, uh-oh. Oh, is right. Are you following? Yes? You guys remember the exactly? Well, what if I gave you something like this? Boom. Look at the different ones. At most, at least, or 5 or more calls. So, with that said, here we go. Let's go over this one. Copy this one, please, on your paper. Because this is a little bit different from the 2 that we just finished. But it's pretty straightforward as well. So. And it reads, a sales firm receives on average 3 calls per hour on its toll-free number. For any given hour, find the probability that it will receive the following. A, at most 3, B, at least 3, and C, 5 or more calls. All right? So here we go. So by looking at the problem, it says a sales firm receives on average 3 calls per hour. So what's another word for average? Everyone? Now that you're in statistics? Mean, yes. And that's what we mean about what? which of these values is the mean? Lambda. Are we there so far? So therefore, the 3 is lambda. Okay, we got that. Do we know the value for E? Yes. All right, so what's the only value that we're missing? X. That's why this is, like I said, a little bit different because they give us different scenarios here. So let's look at this one. Tell your neighbor what at most 3 calls mean. At most 3 calls. All right. Good conversation. Charlotte, what does that mean? At most 3 calls. No more than 3, so that includes what numbers? Yes, 0, 1, 2, and 3. So let's work this part out. So these are going to be our x's. So let me set it up. P of x, the first x is what? 0, semicolon, and what is lambda, everyone? 3. So that means that let's work this one out really quick. So our setup would be E, which is 2.7183, to the negative lambda, which is 3, so it's negative 3, times lambda to the x. 3 to the x, which is 0, over x being 3, my bad, x being 0, 0 factorial. So, tell your neighbor what 0 factorial is. Everyone, 0 factorial is 1. That is correct. And then we bring this to the denominator, so we got 2.7183 to the positive 3rd power. And what is 3 to the 0 power? 1 as well. So, find me that number. 1 divided by 2.7183 to the 3rd power. All right, looks like Illy's got it. Illy, give us a number. 0 point what? .49? Like this? All right, looks about right. Write that in there, please. So that was P of 0 with lambda 3. What is the next one that we need to find? P of 1 with lambda 3. So I'm going to have you guys do that work. I already showed you the process for the first one. Find me P of 1, find me P of 2, and find me P of 3. And of course, with lambda being the same, which is 3 and 3. All right, Illy, pass someone. What do you say that P of 1, what'd you get? Nine what? Looks about right. All right, how about P of 2? Pass someone, P of 2. Just pass it to Jaden over here. All right, Jaden, go. P of 2. point. Okay. Okay, we'll wait for Jaden on that. And P of 3, who are you going to pass it to, Jaden? Who? Hayed. P of 3. So we'll wait for you two. Give you guys a little bit of time. Go. All right. Hold on. All right, so P of 2 is? What is it? All right. Hayed, what you get for your P of 3? 224. That is correct. We're just waiting on Jaden. .224. Hands, have you got that? Looks about right. So now that we have all of them, so what is the probability to get at most 3 calls? What do we need to do with all those numbers? Tell your neighbor. Very good. We find the sum of all of those. So calculators calculate. What's that number? 0.049 plus 0.1493 plus 0.224, 0.224, and Diego says 0.6463. All right, let's go. Okay. So, just leg work here, is that correct? All right, let's go to at least 3 calls. Tell your neighbor what that means. What does at least 3 calls? All right, good conversation. Charlotte, what does at least 3 mean? Anything above 3 or 3 and above, yes? So 3, 4, 5, 6, 7, ... all the way to whatever. Is that correct? So that means, what if there were 100 calls? Are we going to do this for all the 100 calls? You're like, oh, snap, Mr. Q, please don't. Okay, remind your neighbors, what do all the probabilities add up to? Everyone? 1. So that means that the calls before 3, which are what? 0, 1, I'm sorry, let me change colors. The calls before 3, which are 0, 1, and 2, which are this, and this. If we subtract that from what? From 1, that is correct. That should give us the rest of the probability. That make sense? So, calculators calculate, what is For call 0, 1, and 2, 1, 0, 1, and 2. Add these up, these three. Give me that number. Let's see. Jaden's got it. What you got, Jaden? 0.575? 775. 37? So it's 0.5? 0.57775. All right, so no 5. So 0.777. Well, I think you said no 5. 0.5. All right. So to get the calls after 3, which means it has to add up to 1, so we just subtract that from 1, and therefore, what is that number? 1 minus that is 0.423. 4223. Not bad. And that is calls of at least 5. From 1 to 5, I'll come to argue with that. Just a lot of work. I get it. I get it. Now let's look at this one. We're not going to complete it because, yes. The what? The blue and the red? At least. What do you say, Brisela? So 0 is 0.049. 1 is this, and 2 is this. Right? So that means anything before 3. Okay, are you guys messing me up here? Okay, what is 0.5777? Yeah, I know, but what is where did we get the 0.5777? The what? Oh my goodness. I get it. So that means that Jaden should have given me this number over here, so let's change colors. Actually, I'm going to just change this. Here. And bring this as our answer for that. Hands if you agree with that. My goodness, Jaden. All right. Now, check this out. Look up to number 5, part C. It says 5 or more. What does that mean, Charlotte? 5, 6, 7, 8, ... Is that correct? So to find that, tell your neighbor what we would have to do to find that probability. Let's see who can articulate it better. Jaden's going to pass it to someone to enlighten us. What do I need to do first, Jaden? Pass someone. Fernando, what would I need to do first before I found the probability of 5, 6, 7, 8, dot, dot, dot? Okay, so let's look at this part B. I found at least 3 calls. That means 3, 4, 5, dot, dot, dot. What do I need to do first? Areli, what did we need to do first for this one in order to find that? Yeah, find the probability of 0, 1, 2, 3 first. So that means in order to find 5 or more, what do we need to do first, everyone? P of what? 0, P of 2, 1, P of 2, P of 3, P of 4. We find that, and at the end, we just subtract that from 1, and that's going to give us that probability. Okay? All right, I'm going to stop right there. From 1 to 5, how comfortable are you with this, aside from our little tango that we did at the end? All right. I see 23s. Very good. All right, so your home plate for tonight is only 2 problems. You have the code, yes? Yes, Mr. Q. All right. Those that don't have a Nearpod access, there's the numbers, the 2 number problems for tonight using poison. And enjoy your practice. Have a good one. Bye.